In this video, we're going to consider trigonometric applications involving bearings. So the first thing we need to understand is the two different types of bearings. Probably the most common used one in mathematics is a true bearing. So a true bearing is a bearing that is measured from north. So we have a starting point, a north point, and we move in a clockwise direction and measure that angle from north being 0 degrees. So in our first example, we've got this point X that has been created. If I want to find the bearing that we need to walk on to get to point X from, say, this point here, I'm going to put a point O, like the origin. I'm going to place my north point in at 0 degrees, and I'm going to move clockwise to the right. So I need to know that angle there. I can see that we've got the compass points in here, so the angle missing would be 60 degrees. So we would say that X is on a bearing of 60 degrees true. A bearing is written with 3 digits because obviously from north, moving in a clockwise direction, we could move up to 360 degrees. So let's consider going from the origin point O to point Y. So in pink, I'm going to highlight this. So starting from north, moving clockwise, we're going to have to move all the way around until we get to the line where Y is. So we can clearly see that we've travelled over 180 degrees. In fact, we've travelled 33 degrees over 180 degrees. So the bearing to Y would be 213 degrees true. So the capital T is to say it's a true bearing, measured from north, moving clockwise. The other bearing that we sometimes come across is called a compass bearing. And as its name suggests, it's using the compass points: north, east, south, and west. We use these a little bit differently. A compass bearing is given by first with a letter to represent if we're going starting north or south in our direction. It's then we give the angle that we're dealing with, and that angle is between 0 and 90 degrees. And then it finishes with giving a value, the compass point either moving in an easterly or westerly direction. So I'm going to go back to our first example here. I'm just going to remove some of the things that we've written. So if we were trying to have a look at point X, for example, point X is in our what we would call our first quadrant between north and east. So we would start in a northerly direction and we would move towards the east to be where point X is. So we would say X is starting north, and we know that movement is 60 degrees, so 60 degrees towards the east. Whereas Y is much closer to a southerly direction. So we're going to start by facing south, and we're going to move 33 degrees towards the west. So we would say south 33 degrees west. So let's take a look at this in our second example. We've got somebody walking from point A, 5 kilometres, to point B. So in this case, from A to B means we're starting from A and moving to B. So I'm going to draw that angle in straight away. Let's have a look at a true bearing. So starting from north at 0 degrees, moving clockwise, we're going to have to move 135 degrees to get to B. So we would say that we're going to walk 5 kilometres on a bearing of 135 degrees true. However, for a compass bearing, in our case, we're going to see that point B is closest to a southerly direction. So if we were doing a compass bearing, we would say it's easier to start south, that's much closer, and we're going to move towards the east by 45 degrees. So we would say this person is walking 5 kilometres, going south 45 degrees east. So in our third example, we've got, for example, a hiker, let's say, starting at point A. So I'm going to put my compass directions here with our lines at point A, being north at the top, and it's moving to a secondary point before it changes direction to get to point B. So we've got two movements here that we're going to describe using some bearings. So if we were looking at true bearings, what we need to know is how we're moving from north clockwise to that line from point A. So we need to find that angle. I can clearly see it's over 180 degrees. What I'm going to have to do is use the knowledge from the angles at the center here, at that point where we change direction. So I'm going to draw in the compass point there, and I'm going to draw in a compass point at point B. So what these compass points enable us to do, namely our north-south point direction that I'm highlighting in yellow, acts as parallel lines, so we can use the angles in these to help us. For example, I've got an alternate angle that I'm highlighting in orange that would be equivalent to each other, because that line from A to the middle point is acting as a transversal. So this means that that angle here, which is 52 degrees, because it will be 90 degrees with 38, is also 52 degrees over in that orange section. That's very helpful because now I can describe that bearing moving from A. So I'm going to say I'm going to move 6.2 kilometers on a bearing of 180 plus 52 degrees. So that's going to give me 230 degrees true as my bearing. And that's going to get me to this point where we're going to change direction. That means I need to work out what's my change in direction to get to point B. So in blue, I'm just going to highlight that angle that we're going to have to walk here. This is quite an easy one to work out. So I'm starting from north, moving clockwise. I've moved through 90, 180, and even 270 degrees. And I'm going to add on 53 degrees more. So the bearing I'm going to walk on is 323 degrees true. And I'm going to walk 5.5 kilometers on that bearing. A little bit different if we're using a compass bearing. So using a compass bearing, so I'll highlight this in green, we're going to start from point A and we want to move in this direction, which is like a southwesterly direction. So my closest north-south direction is in fact south. So I'm going to start facing south and I'm going to move towards the west, and that's going to be 52 degrees to the west. And I'm going to move 6.2 kilometers in that direction. And then once we get to this center point, I'm going to move up in this direction here towards B, which means that that line is closest to our north point. So I'm going to move north and a certain degrees towards the west. So 360, take that, or 90 in fact, take that 53, or 360, take away that 323 degrees bearing. We're going to get 37 degrees towards the west, and we're going to walk 5.5 kilometers in that direction. So let's take a look at question 2, where we're going to just use that idea of how those compass points form parallel lines and our movements are the transversals, so we can get a real feel for angles at a point and angles in parallel lines that help us with our bearings. So we're going to find the values of x, y, and z. So I'm going to start with x, and I can see that x is to the left of this vertical compass line, and we can also use the compass line at the 60 degrees. They are co-interior angles, so the 60 is acute, so x must be obtuse, so that tells me x is 120 degrees because they are co-interior angles, so with the north points. Okay, for our second angle y, I'm going to highlight in blue, that's using that compass point, and I can use the compass line that is making with 32 degrees. So once again, y and 32 degrees are co-interior. So that will make y 148 degrees because it's co-interior with the north points again. So 32 plus 148 make that 180 degrees. Then what we can see from there is I can easily find this angle I'm going to call A. That's within the triangle, because I know all the angles at this point that I'm highlighting in green add up to 360. So A has to be 192 degrees because the angles at a point equal 360 degrees. This therefore enables me to find Z, because Z is the angles within a triangle, and all the angles in a triangle have to add up to 180. So if we take away the 48 degrees and we take away the 92 degrees for angle A, Z is 40 degrees because of the angles in a triangle equaling 180. So what I'd like you to do now is pause the video, and I'd like you to zoom over to question number 4. Use your knowledge of bearings to see if you can describe the route moving from point A to point B using a true bearing. Okay, let's check our solution. We're starting at point A, moving to point B. So we must put in that north point, and I can see it's going to make a 90 degree with that line. So that's nice and easy. So I'm going to first of all walk 7 kilometers on a bearing of just 90 degrees. Now a true bearing is given with 3 digits, so I've got to put 090 degrees true. My second part of my walk, I've got a north point put in already, and I'm going to have to walk from there to the line leading to point B, which is going to be an obtuse angle. It's going to be that 90 degrees plus the 50. So I'm going to walk 8 kilometers on a bearing of 140 degrees true.